Hello again, here's another A-level maths video. We're in the pure maths year 2 content and we're looking at section 1.4 of the textbook, continuing the work on partial fractions, but this time we're going to extend what we did in the last section of the book to deal with when we have repeated factors in the denominator. So by repeated factors here, I mean that when we've got that same linear factor appearing more than once, like the question on the screen here, we've got x plus 3 over x plus 1 times x plus 1. So that x plus 1 factor has been repeated here. Now this can cause us a bit of a problem, and I'd like to think about that before we get into this in any detail. Why would the form on the screen not be an appropriate way of writing the form for our partial fractions? Okay, so did you have any ideas here? Did you see why this might cause a problem? Well, let me see if I can explain why. If we had these two fractions here and we wanted to add them together, we'd actually end up with something just like this. We've already got our common denominator of x plus 1, and we'd end up with a plus b just combining together to be x plus over x plus 1 here. So really, we just end up with a single fraction. So what can we do here then? Well, let's have a look at the situation here. Now I'm going to do something a little bit clever and a little bit sneaky here. Let's take the fraction that we were dealing with here. And we've seen how we can't just have the form of the partial fractions to be what we had above here. However, if I do this sort of thing here, I'm going to, very sneakily, I'm going to write x plus 3 as x plus 1 plus another 2. Okay, and I'm going to split up the fractions like this. So we have x plus 1 on the denominator here, and x plus 1 on the denominator here. Okay, so I'm just going to pause there to let you think about what I've done here. We've got x plus 3, and I've just written it as x plus 1 plus 2. Now, what that means is I can actually sort of cancel down this here, because I've got an x plus 1 factor in the numerator and the denominator. Divide top and bottom by that. We're just going to end up with 1 over x plus 1 plus 2 over, and I'll write this as x plus 1 squared like that. So whenever we have a repeated factor, a repeated linear factor, there is a way of dealing with it, but we do need to have the second of our partial fractions to be still being squared in the denominator. And that's what we need to know when we've got these repeated linear factors. So just to sum up that, I've put the information on the screen here. If we have a repeated linear factor in the denominator, there's a special form when we're splitting it into partial fractions. If we have that repeated factor ax plus b, which is being squared, then the partial fractions will be of the form a over x plus b and b over ax plus b squared. So one of the denominators is squared and one of them isn't. So let's see how this works in practice then. Here's an example. We'll have a look at this one together. I'll work through it so you can see how it works. But we've got the algebraic fraction there, x minus 1 all over x plus 1 times x minus 2 squared. So you can see that repeated factor of x minus 2 in the denominator. So how are we going to deal with this situation? Well, first thing we need to do is we need to work out the form of the partial fractions, right? So what we're going to have, we have the denominator here, x plus 1 is part of the denominator. So that's not been repeated, so no problem there. We can just have that as one of our partial fractions. And then the repeated factor here of x minus 2, well, what that means is that that's going to become partial fractions where one of the denominators is x minus 2, and another one of the denominators in the other partial fraction is going to be x minus 2 squared. Okay, so that's the first thing that we need to remember here is the form of the partial fractions. Repeated linear factor means we're going to have this situation here. Okay, do you remember what comes next? So the next part of the process was we need to find that common denominator and we need to put all of this together into a single fraction. Well, common denominator we need here is going to be x plus 1 times x minus 2 all squared, because it has to match up with what we've got over here. So I need to multiply a by x minus 2 squared, get that same denominator for that fraction. The b, we need to multiply that by x plus 1, but we also need to multiply it by another x minus 2 to get the x minus 2 squared. Need here. And then the c, we just need to multiply that by x plus 1 to get that common denominator here like that. Just move that here so you can see it. Now, do you remember what comes next? We need to compare the numerators. So the x minus 1 here has got to be the same as this expression here in the numerator for all values of x. And do you remember in the previous video we're using a substitution method to do that? I'm going to pause the process just slightly here because I want you to help me out with the next stage of the process. So question on the screen, which is going to help me out with the next stage of the process. Pause the video, get your answers, and then restart once you've got that. So what do you think here then? What we need, of course, is we need to try and eliminate these things here, make these brackets equal to 0, don't we? Because that's going to make things easier for us. So I think you should have chosen that x equals -1 is a good choice because it's going to mean that any of these x plus 1 brackets become 0 and those terms just vanish. And the other choice, I think, which is a particularly good one, would be x equals +2, because that's the number which is going to make these x minus 2 brackets equal to 0 here. That one there and that one there. So hopefully you agree with me here. Let's just see if we can work through and substitute these numbers in. So if we put x equals -1, the left-hand side becomes -1 minus another 1. This term here becomes a times -1 minus 2 all being squared. And then the other terms just vanish because we've got this x plus 1 bracket here becomes 0, and this x plus 1 bracket here also becomes 0. So that's all we end up with. So what does that mean? We end up with -2 equals 9a, which then gives us the value of a is -2 over 9, like that. Okay. All right, let's just do it for x equals 2. So here we get 2 minus 1 equals, and then here this time, this bracket vanishes, this bracket vanishes, so we just end up with the term involving c. X plus 1 becomes 2 plus 1 here, so this becomes 1 equals 3c, and that means that c must equal 1 over 3. So we found our value of a, we found our value of c, we haven't yet found the value of b, and it seems like, you know, we can't really use substitution to make any further progress because there's no other value of x which is going to eliminate the terms around the b but not eliminate the b itself when we substitute that value in. However, it is worth our while just doing another substitution here. So one way of proceeding from here, I'm just going to sort of get that up here. Oops, hold on, there we go. Is I could actually just substitute another value of x in. Now, I tend to choose 0 when I do this because 0 is a very, very nice, easy one to deal with. And you'll see what happens when I do this. Let's substitute it in here. So 0 minus 1 gives us -1 on the left-hand side. And then on the right-hand side, we have 0 minus 2 in the bracket. If we square the -2, obviously we get a +4. So we end up with 4a there. If we put 0 in here for x, we get 1 times -2 is the coefficient of b. And if we put 0 in here for x, we get just 1 lot of c as the last term in our equation there. So how does this help? Because it seems like, well, we've not eliminated the a or the c here. We wanted to. However, of course, we have got values for a and c now. So we could just substitute those values in and see what we end up with. Let's do that and see what happens. So we end up here with -1 equals, the value of a we found was -2 over 9. The value of b, we don't yet know, that's what we're trying to find. And the value of c was, of course, 1 over 3. Now, if we solve that equation, I won't go through the details of solving it. You can check it yourself if you need to. We solve that equation. It turns out that b equals 2 over 9 here. And that's one way that we can use substitution to find the value of all three of our numbers here when we have a repeated factor here. Let's just finish this off and actually write down the final solution then. So we were asked to express the expression in, or the fraction in partial fractions. We've got x minus 1 over x plus 1 times x minus 2 all squared. So as partial fractions, the fraction here with a denominator of x plus 1, we found that the value of a was minus 2 over 9. Now I'm going to write that like that because that's a bit tidier, right? Put that 9 on the bottom of the fraction like that. And then the value of b we found up here was 2 over 9. So the fraction with a denominator of x minus 2, we would have 2 over 9 in the numerator. If I multiply top and bottom by 9, I end up with that there. And then finally, the fraction with a denominator of x minus 2 squared, the value of c we found was 1 over 3. So if I write that like that, then I've got it in its partial fraction form. So what do you think about that? Quite a lot to do and quite a lot to take care of there, right? Well, let's see how you get on with having a go at one yourself. Here's one with a repeated factor. Pause the video, take as long as you need to get your answer, and then restart once you've got your answer. Okay, so here we are looking at the first part of this process. So the first thing we've been asked to do on the question is just to say what is the form of the partial fractions. So what we need here, I can see there's a repeated factor here. This x minus 1 is repeated. So that's going to become an a over x minus 1. And then we're going to have another partial fraction where that x minus 1 is being squared in the denominator. We also have this x plus 1 here. So that must mean that we must also have a partial fraction where x plus 1 is what's needed there. Okay, did you agree with that? Okay, so let's finish this off then. Now we've got the form. Can you now use substitution and rearranging and do whatever you need to do to find the values of the a, the b, and the c? Over to you. How did you get on with this one? So I've already started my answer here. So when we combine them into the same fraction on the right-hand side of this, then considering the numerator, that's the numerator we should get there, and that's got to match up with the numerator on the left-hand side. So substituting in my numbers, if we substitute x equals 1 into here, the whole thing just simplifies down to minus 4 equals 2b here, which means that's because this term here vanishes and this term here vanishes. So you should have got b equals negative 2. If we substitute in x equals negative 1 though, the whole thing becomes 4 on the left-hand side and then 4c on the right-hand side, which means that c must equal 1. And then if you used another substitution, maybe you substituted x equals 0, that's what I did, then the whole thing here becomes negative 2 equals minus a plus b plus c. And with our values of b and c that we've already found here, b is negative 2 and c is 1, then that tells us that our value of a has got to equal 1. And that's about all I've got to say on this subject for now. Now it's over to you to practice and make sure that you get good enough to do it. You just need to sort of sit down and practice and do loads of them, and then once you've done enough, then you'll know what's going on here with this. So that's the end of this video, and we're going to do a little bit more work with partial fractions before the chapter's finished. So again, make sure you're really good at this, but I'll see you again next time.